Next up, I want to take a quick look at iterator functions, otherwise known as X functions in DAX. And in a nutshell, what these iterators do is they loop through a given calculation or expression for every row within a table, and then they apply some sort of aggregation to that result. So here's an example of what SumX looks like. And in this particular case, the aggregation mode is sum, but this same syntax applies to other X functions like countX, averageX, rankX, etc. So the first argument of the function is a table, and this is the table in which you want the expression to be evaluated. So this could be an explicit table reference like sales, or it could be a filter function or an all function that produces a table, right? So it can be either a physical table within your model or a virtual table. And then the final argument of the function, the expression, this is basically what the calculation that you're trying to evaluate row by row. So it might be a measure, like total orders, or it might be a mathematical operation, like the values in one column times the values in another column. And this took a little while to sink in, at least for me. But what kind of helped was to equate this to a sum product in Excel. And a great example, it's kind of tangible and hands-on, is calculating something like price times quantity. Imagine a price column and a quantity column, and you run a sum product, which basically calculates price times quantity in row 1, price times quantity in row 2, price times quantity in row 3, over and over and over again until it gets to the very last row in the table. And then it takes the result of each of those multiplication expressions and then sums them up. So it might be helpful to think of these iterator functions as adding a temporary column at the end of the table where it stores the result of each of these expressions for every row as it works through the table. And then once it reaches the end, the final row of the table, it aggregates the values in that temporary column based on whatever the function is. So if it's a SumX, then it takes the sum of those results. If it's a countX, it takes the count of the results. If it's a rankX, it determines the ranks based on those results. So that's how these iterators are really working. And to show you an example, what I'd like to do is head back to our AdventureWorks report, and we're going to try and recreate the revenue column that we generated with the calculated columns, and we're going to see if we can convert this into a measure using the SumX function. All right, so open up your Power BI report, and we're going to head over to the Data tab. And here I want to start again from that sales data table, and I want to take a look at our retail price and our revenue columns. And so these two columns were created during the calculated column demos. For retail price, we had used related. We're bringing in the related product price column from the product lookup table. And then for revenue, we're simply multiplying retail price by the order quantity. So this isn't incorrect. I just want to state that. There isn't anything that's wrong necessarily about this. We're getting the right values. It's working just fine. And our table and our data set is small enough that we're not really noticing any sort of performance impacts. It's not impacting file size or speed or anything like that. But if we're looking at this as perfectionists and we're trying to build the leanest, the most efficient model possible, what we could do is try to replace both of these calculated columns with a measure. And the reason why we would want to do that is so we're not stamping redundant data here in the table. So let's see if we can make that happen. Now I'm going to head back to the report view, and we're going to mess around with our matrix a little bit. Kind of want to update this to streamline it a little bit. So we'll pull everything out. And we're going to keep it showing our category names. And then I want to bring in quantity sold. And then we're actually going to create a temporary new measure. And we're going to call this total revenue CC. And what I want to do is I basically just want to sum the revenue column from the sales table. And I'm doing this because we're basically going to check our work against this column throughout the lecture. But I want to make sure that we have a way that we can visualize the total revenue from that calculated column within our matrix. So again, we're currency. Looks like this is formatted. and we'll bring in our total revenue calculated column measure here. I'm going to change these decimal points down to 0. Awesome. So we've got our table set up with our quantity sold and our total revenue calculated column, and we're looking at it by category name. All right, so from here, we're going to create another new measure, and I'm going to call this total revenue. And let's think for a minute how the original version of total revenue was calculated. We were taking the values from the order quantity column and multiplying them by the values of product price, which we had pulled into the sales table using related. So maybe the instinct is to start with something like that. Maybe we try to reference the quantity field, and we see that DAX is actually not allowing us to do that. All I'm getting is my measures here. All right, same thing if I try the product price. I'm not able to bring in any of those columns to this measure. And what this is DAX reminding us that we can't just reference blanket columns like this. We need to add some sort of aggregation because DAX doesn't know what to do with a full column of values and no further instruction. So what if we try to indicate or add that aggregation right here in the formula? So instead of just the quantity column, maybe it's the sum of quantity. All right, so let's try that. And then what we want to do here is I want to multiply this by the sum by our sales data retail price. All right, so we're going to lock this in. All right, everything is looking good so far. We're not getting any errors. All right, so we're going to bring this into our matrix, and we'll check out what we get here. All right, so this is absolutely out of control. Basically, what this is saying is, for clothing, we have sold 12,436, and we've generated something like $3 billion in revenue, right? Which is just absolutely insane, right? So this clearly doesn't make sense. And if we go back to our total revenue calculation here, we're summing these retail prices, and it's pretty clear that that's our issue. So what we could try to do is something like average. And again, that returns something a little bit better. Like if we're comparing this against our total revenue calculated column, we're kind of at least in the ballpark here, but again, it's still not right. So what we've got to do here is we've really got to just start over here. This isn't the right way to start calculating this. And what we really need here is some sort of function that could evaluate an expression for each row in a table and iterate through that whole table and apply an aggregation to the result. That would be exactly what we need here. And I think you see where I'm going with this. So SumX is going to be a great fit for this. All right, so we'll start typing and then kind of walk through it. All right, so SumX, our first argument here is a table. And this is the table that contains the rows that we're going to be cycling through to evaluate these expressions. So if you think about it, what table is that going to be? It's going to be our sales table. And the expression that we want to evaluate for every row within the sales table is going to be that same calculation for revenue, which is price times quantity. So we can type in quantity. We have order quantity. We can now access the actual column itself, order quantity. And so this is going to be order quantity times the price. And what you'll notice here is that I've only typed in price. And if you remember, there's actually a couple of different price options or columns within our total data model. And you'll notice that the price column from the product table isn't even an option here, right? I get my sales data retail price and my measures, and then any DAX functions that contain price as well. So the reason for this is because we're performing row-level operations or row-level calculations within the AW sales table. So DAX is telling me that I've got to grab columns from within the same sales data table. All right, so we'll click to select this column, return down, and now we can close this formula out. All right, same thing here. Let me just update the decimal points so we're kind of looking at the same values side by side. And there you go, right? So now we've created a measure that is producing the same exact value as when we're summing our calculated column. So in the spirit of making our model more efficient and reducing redundant data, that means that we can now go back to our data tab and we can delete our revenue column from our sales data table because we've just reproduced that. So I'm going to right click, delete. Yes, I'm sure. All right, and we'll head back to our report view. You can see that we have an error here. Again, that's expected. Basically, we've deleted this total revenue measure. So Power BI doesn't know what should be in there. All right, so basically, if we go through and we delete that total revenue measure from the model, right, that calculated column one that we were using just to check our work, we see that we're good to go now. So we've got our total revenue measure using SumX, right? It's still there. It's still correct, still fully functional. We've eliminated an entire extra column of data. And now if you really want to get crazy, we can eliminate one more column as well. I'm going to give you a hint on how we can do that. So looking back at our data view here, remember the retail price column was brought in using the related function. And what we can do is actually follow the same exact logic, but instead embed this or nest it inside of our SumX that we just wrote. So instead of referencing this column, we can actually use related within SumX to query or to return the product price column from the product lookup table. All right, so let's head back and show you how to do this. All right, so from here, basically what we want to do is update this reference. So from here, we're still going to say, hey, we want to multiply the order quantity column from our sales data table, but we want to multiply that by a related column. And at this point, you might be saying, hey, I thought you said that we could only access columns from within the sales table. And I kind of lied. We can access columns from other tables, but the only way to do that is to use some sort of function like related that allows you to access those other columns. So just like we pulled in the related field into the sales table itself, we can access those values from the related field inside of SumX. All right, so here we're going to do related and then our product lookup. And we can come down here to product price. We'll close our parentheses. And then we got our same parenthesis close on SumX. Just to reiterate, this is the same exact logic that we were using when we use this as a calculated column, except this time it's fully contained within a SumX function. So press enter, and we should see that our values still hold the exact same here. All right, that's updated, and we've got no change to the values within our matrix visual here, which is exactly what we want. All right, so there's one last little step here. We can actually go back to our sales table, and we can delete our retail price column. We don't need this anymore. All of the information that we now need is built into a single measure, right? That single SumX iterator function contains all of the data that those two columns were containing. So bottom line here, we just removed two entire columns worth of data without actually losing anything because we essentially just transitioned the calculations out of columns and into measures. That's SumX. The other X functions work in a very similar way. The only difference is the actual aggregation step that happens at the end. All right, so now that we've done all that work, we can actually create a new measure that uses those two measures we just created as components. And this is going to be called average revenue per customer. So it will come up and we're going to create our new average revenue per customer measure. And for this, we're going to use the divide function. And like I had mentioned, because we had just created those two new measures from those calculated columns, we can call those measures right here. So total revenue, and our denominator is going to be our total customers. Close out our parentheses. We'll lock this in. Do some updates here. Make sure we assign this to our measure table. And currency, we'll update this to 0 decimal places. All right, so again, we've got our average revenue per customer measure. And again, super easy to create this using a divide function and those two brand new measures that we cleaned up and created within the model.